right. Let's kick it off by some introduction about you. So you can brief us around your background and how did you professionally engage in crypto space?
Yeah, sure. So my background is in software development. I did programming for manufacturing companies for about 10 years. And then before that, I was in web development. And in 2018, I decided to find something else that was interesting. And I thought Ethereum was interesting and blockchain. So I started learning about smart contracts and Solidity and got interested in the standards, ERC 721, and participated in some of those early discussions of that token standard. And then I got interested in the composable non-fungible tokens, where you could have like one NFT own another NFT, things like that, and started building stuff. So in 2018. So that's really my background and how I got started.
All right, great. So, for the people who are late, in the space, and they're just discovering, just scratching the technical surface of this space. Can we just, in a nutshell, describe what is a token standard? What it's EIP?
Yeah, so EIP 2535 diamonds, or also known as the diamond standard. It's a way for handling larger smart contract systems, like where you're going to have to use more than one smart contract to build something, and so it provides an approach to building a multi-contract system. It sort of provides kind of a standardized way to organize things and to do things, and provides a way for upgrades, and provides a way for you a standardized way to look at, well, what are all the contracts in the system, and tooling for it, stuff like that. So it's really it's supposed to make a multi-contract system simpler and more standardized. And so there's different aspects to it. So, but in a brief nutshell, I'd say that.
All right. So, what was that initiated the spark in your head? So, you started elaborating and working on that approach. What were the bottlenecks in the existing smart contracts landscape?
Sorry, what was the what?
What were the inefficiencies in the ways that the smart contracts were built? So you spotted them, and the EIP 2535 was the answer.
Yeah. So what happened is I was working on another standard called ERC 998, which is this composable non-fungible token standard. This idea of, what I said earlier, an NFT being able to possess ERC 20 tokens or other NFTs, things like that. And I was working on a project called Mokins, which is an ERC 721, but also ERC 998, so it could hold other assets within it, these NFTs. And while I was building that, I ran into the maximum contract size limit, because a smart contract is limited to about 24 kilobytes. So then I did things to try to reduce the size and stuff, but it wasn't enough. And because this was an NFT contract, I wanted my NFT to come from one address, one Ethereum address, and it didn't really make sense to have like an NFT that came from like somehow other multiple contracts. And so then that's really when I started solving the problem of, well, how can you get around this 24 kilobyte maximum size contract size, thing? And So that really began in 2018. That really began the research into solving the problem, and so Diamond solves that problem where you can have one Ethereum address, and you can have unlimited smart contract functionality coming from that one address. But once that problem was solved, then I realized that it started solving other things like, well, if you're going to have a larger system, then how are you going to organize it? How are you going to write your smart contracts and organize your code? And so it solved an organizational problem there, and it solved other problems like when you have a multi-contract system, you might have a lot of cross calling where you have external calls between contracts, and they can get gas expensive on some blockchains. And so it provided some gas efficiencies, and it provided some standardization for certain aspects, and it solved some upgrade things like, the common upgrade. It's common for upgrades where when you're using a proxy design, you're going to do an upgrade, you have to deploy another contract.
Redeploy again. That's why we have version 1, version 2, version 3. Exactly. Yes. So, and I will get you back a bit to elaborate more on that modular part of the smart contracts, and I will try to break it down to a level that everyone can understand. So, would this be correct if I said that the modularity is like, I will use a term from a game, for a children game. Would you say that it's kind of like a Lego, when we can add some bricks and do not need to make again the whole game through its base, so we can just add or remove pieces to have a different, let's say, construction?
Yes. So the modular is this idea. That's right. Where you can build an independent piece of software, and which is a module, and be able to, you can create these different modules and be able to add them to your existing system or other systems, and each independent thing has one aspect to it, or one set of aspects to it that are aligned together. So that's definitely true with diamonds, in that you can create the basic idea of diamonds is that you have a smart contract, and that smart contract gets its functions from other contracts. And so you can create this other contract with functionality, and then you can add that functionality from that contract to your diamond or another diamond. That's where the modular part is you can create the smart contract functionality and reuse it in different diamonds.
So we read, of course, in the articles around the diamond standard. So we have the term diamond and the term facets. Can you elaborate on this? Why it's called diamond, and what are why the term diamond, and what are the facets?
Yeah, sure. So the diamond is the smart contract with the Ethereum address. It's like it is that out the outside uses to interact with your system. It's like the smart contract that provides all the functionality that external things talk to. And so that's the diamond. And the diamond gets its functionality, as I said, from other contracts. And these other contracts are called faucets. And so a diamond can have unlimited functions from an unlimited amount of faucets. And so the terminology, it comes from the idea that when you make a diamond, a diamond, which is this contract, and you maybe just to give an example, maybe it's the diamond is implementing ERC 721, which is a common NFT standard, and so you might have a faucet that has that. And so so in your diamond, you have this view of it. You could look at it as, okay, this diamond has a set of functionality for NFTs. And so it has that aspect of it, that side of it. Okay, now let's say you're going to add some kind of staking mechanism where you can stake those NFTs. And so you create another faucet with some staking functions, and then you add these staking functions to your same diamonds. Now your diamond has like a different aspect to it, a different view, a different set of functionality, and that's what a faucet is on a physical diamond, is as a side of the diamond. A diamond can have many different sides to it. And so in our smart contract diamond, now we have two sides of our smart contract diamond. We have our NFT stuff and we have our staking stuff. And so we have these two sides of our diamond, our views to it. And then if we wanted to add some other kind of functionality, let's say some DAO functionality, some way to on-chain way to govern how our NFTs work and the settings of our staking. And so now we have some new DAO functions that and a new DAO faucet when we add some functions for that DAO and add them to our diamond. So now we have three different views, three different faucets of our diamond. And so that's kind of the idea of here is that, and there's some other technical aspects, because all three faucets, they're storing their data in the same place, which is the diamond contract, and that's where their data gets stored. And so they have a common center, or whereas in a real physical diamond it has all these different sides, but they all share the internal kind of center of the diamond.
Very interesting, very interesting. Personally, I was blown away when I first was introduced to all this new way of building smart contracts some months ago. Yes, it completely blew me away. So again, to break it down in a simple way, we can say that the diamond is the core structure of a smart contract, or a core smart contract, and it has kind of open sockets, and the facets are other smaller, maybe smart contracts that they can hook in each socket if they are compatible with. Correct?
Yeah, you said that they can be compatible with each other, like you could use the same faucets in the diamond. Is that what you're saying?
No, I said that, for example, in the diamond, you have different sockets or openings. So for NFTs or other ERC standards, and the facets, according to in which sector or which ERC they are built on, they can choose the correct socket of the diamond to hook in.
Yeah. So different faucets can implement different standards, and they can be added to the diamond.
Great. Very, very nice approach. Very intelligent approach. So
let me just add one thing to this. One part of this modular, part of this module design. One way of looking at this, when some projects you launch on the blockchain, you want it to be launched and that's it, and you don't want it to change and that's it forever. And other projects, you might want to release some initial functionality that's useful and that gets a project started. And then once people start using it, you can see which direction you want to take the project, or you get user feedback. You find out what's good, what's bad, what people want. You find, and then you'll want to add more functionality to your smart contract system to implement the next set of functionality based on your user feedback. And so and in this case, you need a smart contract system that can be extended after deployment. And so that's really something that the diamonds, the standard here is really good at providing, because you can launch your project and then later on you can add another faucet, another set of functions to your diamond, and you can keep adding new sets of functions in a systematic, organized way. And so that's something that people leverage when they know they want to grow a project over time.
infinite upgradability. So very, very powerful thing. So very nice, great. When people hear this for the first time, and even me, that I have some friction already, although I'm not a developer. When we hear all this fancy and very interesting technical description, it sounds like it's a bit complex to build smart contracts based on the EIP 2535 standard. Would you say that it's a whole lot complex than what we were used to, or it's just a matter of developers adapting to it easily with the right guidance and just reap the benefits of it?
Yeah, so I wouldn't say that building smart contracts with EIP 2535 is complex. I would, it's certainly more complex than using like one smart contract. And I think the complexity about your EIP 2535 is misplaced. And the reason I say this is I think that what's actually gets complex is having a multi-contract system. So if you have a set of contracts and they're calling each other, that's what gets complex. Like you have 5 different contracts and they're calling each other, and okay, now they're all emitting different events. And now if you want someone to work to interoperate or to leverage your smart contract system, you can't just give them one Ethereum address and say use this address. No, you have to give them 3 or 2 or 4 or 5 different addresses with different functionality and emitting different events. And so I think that's more complex than just having a single Ethereum address and say all your functionality is at this address and all the events are emitted from this address. And so I think that's simpler. I think what's complicated is when you have a lot of different smart contracts that are kind of intermeshed, calling each other in various ways. And so I think the other thing that gets complex is, someone who's not very familiar with the Solidity language and how it works and how the storage works in smart contracts. So the diamonds thing can appear complex to some people because they're not that familiar with Solidity, and because they're now working with multiple contracts. Because even with the diamond, you're working with multiple contracts. There's some complexity there because you're just working with more functionality and you're integrating that functionality together. So I guess my point is that if you're working with a multi-contract system, it's more complex. It's more complex if you're using the diamond or if you're not using the diamond. I tend to think the diamond makes multi-contract systems less complex because it provides an organized and systematic way or orderly way of going about it. So there is some learning overhead of like, well, how does the diamond work? And then, how does storage work? But really, if you look at what EIP 2535 is, it's not very complicated. It's actually pretty simple. It's a contract that uses other contracts for its functions. That's one part. So I'll say it again: a contract that uses other functions from other contracts, and then it has its own. Every diamond has its own set of 4 functions that are introspecting, meaning they tell you what's in the diamond, what functions are in the diamond from what faucets. So that's the second thing. The third thing is you can add, remove, or replace functions in the diamond. That's its upgradable functionality. So you have that. That's actually optional as well. Diamonds don't have to be upgradable. They can or cannot. So you have that third, and then the last thing is you have an event that gets emitted anytime you add, replace, or remove functions. So this event is a way to track upgrades on any diamond, and that's really the 4 pieces. And so that's not very. I don't think that's very. That's only 4 things and that's it.
Totally get you, and of course it gives the perspective. For all of us who are, again, I want to point that we are not developers and we are trying to figure out through all you OGs in the space, especially in the technical sector. So yes, I get that building with a, let's call it the previous way or the alternative way, creates more challenges, and it's maybe more difficult in order to facilitate the bridges to begin with, and also to have all these structures secured. So yes, I get your point that having one diamond contract and some open sockets for the faucets, it's way simpler and a lot more efficient. I totally get your point. So until now we have mentioned through our questions some of the benefits of implementing EIP 2535. If you were to choose the top three benefits, what would that be?
I'll answer that, but I just want to say that the standard was also designed with flexibility. So like sort of the benefits of the diamond can be some things in some systems, the benefits, some systems can leverage different benefits from the diamond. So it's like every project is different. And if I get going again with that analogy of a diamond, every diamond is different. There's big diamonds, little diamonds, different shapes and everything. So, and also just mention that the diamond analogy is analogy. Some people like to poke holes in the analogy. There's definitely holes in the analogy. It's not a perfect analogy for sure. But the benefits that I like about the diamond and I see people leveraging is the one Ethereum address for a lot of functionality and events, making it simpler for testing and for other projects to communicate with a project, because they can deal with less addresses or a single address for a lot of functionality. So that's one. Another benefit is having a way to get around the 24 kilobyte max contract size, and so solving that issue. The other one is the idea that you can launch your smart contract system and then have a systematic, easy way to upgrade it to add more functionality over time without having to redeploy everything. You just create your new functionality you want, and you just add that to your existing diamond. So that's just that. And then if I was going to do a fourth, which you didn't ask for, and this aspect is something I see coming in the future, that's already being worked on and developed, but I see it more in the future, is reuse, on-chain reuse of faucets for diamonds. So that means that, okay, you've got an ERC 721 faucet, you deploy it. Now, because I see this going across, people take the code for a smart contract and they deploy it, and then, someone else deploys the same code, Open Zeppelin, that code gets deployed over and over and over again. But with diamonds, you can deploy the code one time onto the blockchain, and then you can reuse that on-chain contract in other diamonds and other systems. And this faucet can work with other systems, and so you have this on-chain reuse, which of course can save you deployment cost, and it can also be a security benefit, because if you have a faucet that's already been audited, it's already on chain, it's already been in production by other projects, and now you're just going to reuse that existing thing, it's going to be secure because you're not deploying anything new, you're just using something that's already stable.
Yeah, I mean, now that you're mentioning it and you're describing it, it seems like a top way to address functionality and efficiency. So very, very, very big step. Yeah, this will be great. Are you considering doing that in the upcoming months, or it will take longer?
Well, there's a few projects I know of that are working on this sort of thing.
Mm.
One of them is Flare. There's another one. I kind of forget the names of the other two. So I'm not quite sure where they're at right now. But there's so I don't know. I don't know how long it'll be for it to be in more use. But I just know it's being worked on and being done.
Let's say during the next year, for example.
Well, I mean, it definitely could over the next year. It could definitely be, products, and it could definitely be done. Like, there's nothing technically stopping it from being done, and it's not very hard to do. It just takes someone wanting to do it and doing it. So it doesn't. I'm not going to be the one who does it. It's these other people. So I can't say for them what they're going to do or when they're going to do it. But I just know technically, it can be done, and that people are working on it and doing stuff with it. So.
Got it.
Yeah.
All right. So you can understand that the following question is a totally upcoming one, since we were mentioning benefits and what are the use cases and all the positives. But we all know more or less that with every new feature or with every new way of building stuff, and not only in crypto and smart contracts, but in the rest of scientific sectors, there might be some weaknesses or some challenges or some initial problems, difficulties, I don't know. Have you witnessed occasions like this or points like this in your journey while building the EIP 2535, and how did you address them?
Oh, like problems or weaknesses?
Mm-hmm.
Yeah, I think well, when it was being developed, it was going for things like maximum flexibility, but adding making certain things standardized where it mattered, like the event that tracks upgrades. Making that standard is important, because then you can build a tool that shows or tracks upgrades for all one tool that works for all diamonds. So that's a point of standardization where we have that interoperability. So security was a big factor in the design. And the diamond, the way it's designed is certain points are designed the way it is for security. So getting, early on, that wasn't exactly right, and that was adjusted so that it was designed for security on some points. So, like, for example, one of when you're adding functions or replacing them or removing them, there's a slight possibility of the diamond doesn't have this possibility. Its design erases it, but this is just one of the things one of the reasons it's designed the way it is that you didn't want to add a function that has, so functions, when they're added, they're reduced to a 4-byte value, which is you hash a function's name and its argument types, and you get this hash, and you take the first 4 bytes of that, and it's called a function selector. And so a function selector is how a contract knows which function is called. And so when you're adding functions, you're actually adding this 4-byte selector into the contract. And there's a possibility that when you add a function that you have more than one, you have different functions with different names, and they have the same 4-byte selector. So you might be trying to, my point is, you might be trying to add a function and you accidentally overwrite an existing function. Because they have that same selector, and so this is called selector clash. And so the design of the diamond prevents that. When you're replacing functions, that the upgrade function is able to detect, is there any functions when you're adding, are you going to replace something? And if you are, it will revert the transaction. So that's just another example. There's other little security aspects that so just kind of knowing what those are, overcoming those, and it's not really hard. It's just getting the design right. Let's see. I think really the big thing with overcoming with the the design of the diamond was the diamond was written and done originally where it had a storage problem originally, where all the faucets, any storage you were going to use in a diamond had to be defined, and that the definition of that storage then had to be included in every faucet that was going to be in the diamond. And that made faucets not reusable, because if this faucet was going to be in this diamond, it had the same definition of the data storage. So if you try to use that faucet in another diamond that used different storage, then the faucet could never work. And so that was early on the problem with the diamonds, is that the faucets were not reusable because of this storage definition problem. But then later, the Solidity language changed and provided this brand new way of storing data in contracts, which then I called the diamond storage. And I wrote an article about it the day this functionality was able to come out. And so then that became a challenge. Okay, there's this new way to store data in contracts that just became available because the language changed. How do I get people to know about this and know about its benefits and why you should use it? So this diamond storage should not only be used by diamonds in EIP 2535, it really should be used in any upgradable smart contract system that uses a proxy. When I say proxy, the proxy is this idea is you have a smart contract and it uses functions from other contracts. That's a proxy. And so so even Open Zeppelin has announced that in their next major version of Open Zeppelin, they're switching to this diamond storage because it's a better way of it's a better way and a safer way to handle storage for these upgradable contracts. So anyway, so that was a challenge, is getting this new diamond storage way of organizing data in smart contracts, getting that known and getting people to write about it and that sort of thing.
Great. Thank you very much for the elaboration. At this point, I want to introduce some people from our team here. We have Ayushman from our community, and we had also Zephyrin from our. He's a blockchain developer. So guys, you can say hi, and Ayushman, you can take over, and because I know how excited you are for this AMA with Nick, and take some questions so we can wrap it up.
Yep. Hi, Nick. Hello again.
Hi there.
Yeah, so it's morning for you, right?
Yes, it is.
Awesome. Like, it's night here in India. It's 7 o'clock. Yeah. So I got to know more about the difficulties you faced while coding the diamond storage part, and it's interesting to know because how there's the strong features, there can be some weaknesses or difficulties in implementing, and I am glad you shared it with us. So I wanted to know from the user's point, is that would users know the difference between the dApps which are using this EIP 2535 which is modular upgradable smart contracts, and dApp not using it? Will there be a difference in the user flow of the dApp?
So that it'll depend on a particular project and how they want to do things. So in other words, I'm saying it really depends project per project. In some cases, yes. In some cases, it'll affect the end users. For example, I know there's some projects like Beanstalk where they have a DAO, and they allow users to vote on, okay, we want to add this new functionality to our diamond or to our system, and then you vote, and if you can, and that might be a way users know that it's a diamond, that they can know that their project's functionality can change or grow based on so they could know that way. They could know if there's a project that's deploying a diamond for each new user into their system. and this diamond acts as like a wallet, a contract wallet, or some kind of functionality for a user, and every user has their own diamond. Then you could like allow a user to each user can then later approve upgrades to their diamond to add new functionality, or to add different modules to their diamond. So like if a project is organized in that way where each user gets their own diamond, then of course users would know that, oh, this is diamond stuff. I can add and remove things to my diamond. So that's another case. Other cases, a project might be using diamonds for example, they want to grow their application, or they want to simplify if it's a bigger contract system, they want an organized way, as sort of a standardized, organized way to handle a larger system. Then the user might not ever know it's a diamond, and they don't ever tell you, they don't tell anyone, and they just use it for their own development purpose. So in other words, it could be visible to the user and affect the user, or the user could be aware of it or not.
Right, got it. So like it's up to the projects, and as well as the opportunities is like endless. Like it can depend on the user. They can approve of the decision for the diamond storage, diamond standard. And yeah, I mean, like that's very flexible, like, about how it can depend on the project and depend on the user. Let's see like how projects use it then.
Yes.
Yeah. So okay, so coming apart from like the whole diamond standard and EIP 2535, would you like to tell our folks about what perfect abstractions is, and like what you work there, like what work do you deal with there? Because like from the website we saw that that you've mentioned like what perfect means and like what abstraction means, and like together what both of the word mean. So could you tell our folks here?
Yeah, sure. So perfect abstractions that I founded, we are, and I have a business partner named Arthur Nesbitt, and we have some security auditors. So we're delivering security audits on smart contract systems, and what I'm currently doing is we have an audit test where someone who's interested in being a security auditor for us, I have them do this security auditing test so I'm and we let pretty much anybody take this test, but then I review and I grade these security auditing tests and help evaluate hiring someone, another security auditor. And when we do security audits, I review our security audits before they are sent to the client. So I guess my job is ensuring the quality of our security auditors and looking and that's the quality of our security audits. And so that's what I'm doing there. So that's what I'm doing there, and I'm working to grow Perfect Abstractions to do more security audits and get more auditors.
Right. So folks, if you are an auditor, you can surely approach Nick, right? And I've just put it up on the spaces right now, so you can check it out. And because like security is one of the most important things in Web3 and especially in crypto, because once you're storing your real money, you would want it to be secure and in a trustworthy project. So Nick here helps us to do quite that only. Appreciate Nick. And one final thing which we wanted to say was, after mentioning again that we are very proud to have you as a technical advisor. So how do you think like hashtag and even DeFi projects in general will benefit from building with Diamond?
Well, I think they'll benefit from the standardization and the code organization. I think as well as more developers know and understand the diamonds, get familiar with it, they'll be able to go from diamond project to diamond project more easily, because they'll be using the same pattern. And so I think it can help bring up to speed developers on projects. And I think Hashtag can benefit from that and from the organization from it. I think Hashtag and other projects can benefit from the tooling that exists for it and future tooling. Like there's the Looper website, and I just see that people will create more tools to help with upgrades, to check things, security things with storage, things like that. So I think as the ecosystem grows and gets bigger, it becomes more kind of beneficial for everyone, the standard. Yeah.
Right, got it. So the more the adoption, the more the facility of sharing the same ecosystem.
Yeah.
Right. Yeah.
Yeah.
So now that we're almost coming to an end, um, I'd like to ask, like, if community, do you guys have any questions to ask to Nick about EIP 2535 Diamond Standard? Feel free to ask. You can raise your hands and request for speaker. Okay, Dhruv here will grant you access, and you can ask your questions.
Come on, guys, don't be shy. Don't be afraid if you ask something that it's not correct. We do not judge anyone. Everyone makes mistakes. We did all, and we are going to do again. So we don't bite. Just raise your hand and take the stage.
I don't think anyone has raised their hands. I think they're pretty clear, like how Nick has summed up the diamond standard for us with the benefits, the difficulties which he had faced when creating it, and of course, like the whole ecosystem, how it can benefit it.
Yep, totally agree.
One of the things I just want to say that I'm looking forward to seeing is the standard is pretty flexible in what can be built with it, but I think that more standards can be built on top of EIP 2535, like storage, like I think Hashtag has helped with that. I think that sort of methods or ways of building things, building certain things can be built on top of EIP 25. Like, okay, this is how you build staking on using EIP 2535. This is how you do BLA with diamonds. So I'm kind of interested in seeing people develop more special use case ways of doing things with diamonds, building on top of it that way. And I think anyone who uses diamonds again will benefit from people creating these ways of doing things with diamonds.
Yep, we are excited about this too, Nick. As you know, DeFi is all about multi-chain and integrations and dApps talking to each other and creating bridges. I also think that the more this space uses a diamond standard, it will be a lot easier, more efficient, and more secure for DeFi space as a whole. So since we don't have anyone here to ask something, we can wrap this up.
Aris, I think Zephyrin has a question. Zephyrin, you there?
Of course. Zephyrin, please.
Yeah.
Hi, Nick. So I had a question, like not exactly regarding diamond, but regarding it was regarding about factory contracts. Like if I wanted to use diamond standard and diamond upgradability in factory contracts, like upgrading the factory contracts as well as the default contracts, like what would be the best way to implement it? If you have any suggestion.
If you're going to do what? Sorry.
Upgradable factory contract, like there is a factory contract which deploys like another contract. Let's say,
Yes.
yeah, crowdfunding, like it deploys another contract for different users. And how would you implement? What would be the best way to make it upgradable?
So you got this factory and you want to deploy an upgradable contract. So I think that you would just do that factory to deploy, the upgradable contract the same way you would do it the same way you do it off chain. So that factory would deploy a proxy contract, and then you'd have to connect the implementation contract to the proxy, either by calling the proxy, or maybe the factory could do it somehow. So you would just apply however you usually deploy the upgradable contract. You just apply whatever's usually done to deploy that upgradable, and you just migrate that to on chain into that factory. So I'd have to look at the details, but you can definitely do that. You can definitely have a factory contract that deploys your upgradable contract, your proxy, and connecting it together and stuff. So just look at how it exists right now, and apply that, modify it to work in a factory.
Okay. Yeah, got it. Okay.
Yeah, and diamonds can be done that way too. I've seen that where people have a contract that deploys diamonds, and have this factory that deploys diamonds, and that can work too.
Yeah. Okay. Thank you.
Mm-hmm.
Great. Thanks for this explanation, Nick. And again, guys, it's time to wrap this up. And since I think there's no one who wants to claim the stage and ask Nick, yes, we can finalize. And Nick, again, it was a really great opportunity for us and our audience and people who will hear the recordings after, to learn more about this very, very powerful tool and innovative approach, which is called Diamond Standard. Again, we are very glad and proud to have you as a technical advisor. I know this will evolve in building great stuff together, as we already have. So guys, all of our community here, thank you for being with us. Please follow Nick in his Twitter at Mudgen, Mudgen. Also, his website is www.perfectabstractions.com. And of course, feel free to visit Hashtag's website at hashtag.finance and our Twitter at 0x#. Have a nice evening or have a nice day. Regarding to the time zone you are in. And Nick, again, it was a real pleasure for me and for the team to have you here.
Thank you so much, Nick.
Thank you, guys. It was a pleasure for me as well. Thank you for having me.
Yeah, hope to see you soon and talk to you in a meetup or in a conference.
That would be great.
Yeah.
Sounds good.
Yeah. Thank you so much, community, for coming in.
Bye-bye, everyone.
Bye, everyone.